Welcome to lecture number 5 on Mathematics 164. This is a Precalculus Mathematics with New Jersey City University. Today, our main topic is to discuss about operations with algebraic expressions. So an example of operations, we mean the arithmetic operations such as addition, multiplication, division, and also subtraction. So again, operations with algebraic expressions. This is again lecture number 5 on Mathematics 164 Precalculus. So we know that in algebra, we usually use a combination of real numbers such as 3, 5, we have 6 by 7, or negative square root of 2. And also with letters such as X, A, M, it can be any letters. And normally we call the real numbers as a constant values, and we call the letters as variables. And a good example would be a polynomial in X. So this is a general form. Again, when we use the term polynomial, we mean the algebraic expression with more than one term. For example, let's use this example here. If I have only 4x cubed, we call it monomial because it's only one term, mono. If I have 4x cubed minus 2x, we call it binomial. We have two terms. Now 4x cubed minus 2x minus 3, we have three terms now, so it's called trinomial. In general, we are going to use the term polynomial. So this is a polynomial form. Here our variable is x. So a can be any value, or we can use the term coefficient. A will be the coefficient of x raised to the power n. Then we have an minus 1. It's a coefficient of x raised to the power n minus 1. Then a0 will be our constant value. So example here again, 4x cubed minus 2x minus 3. 4 is the coefficient of x cubed, and negative 2 is a coefficient of x, and negative 3 is a constant value or constant term. We also have the degree of a constant terms, which we always say is 0. So in our expression, previous expression, 4x cubed minus 2x minus 3, the degree of the constant value, negative 3, is 0. Now the degree of negative 2x is 1 because x raised to the power 1. The degree of the term 4x cubed is 3 because x raised to the power 3. Now the degree of 4x cubed minus 2x minus 3, we are going to count the exponent here. We have 3 plus 1, which is 4, so the degree will be 4. We know constant value degree is 0. And that's what we met here. Example here also, we have 4x squared y is 2 because x raised to the power 2. Y is y raised to the power 1, so it will be 2 plus 1, which is 3. Constant value again, the degree is 0. Now, if I have 6xy, the degree will be 2 because x, the exponent is 1, y, the exponent is 1. So it will be 1 plus 1, which is 2. And the degree of any constant value is always 0. So let's try an example. So I already said about the term binomial. So you say if a polynomial containing two terms is called binomial. And also we have mentioned about the monomial. Monomial means we have a single term polynomial as a monomial. So if I have, for example, only 4x squared y, this is again monomial. Now if I have 6xy, let's say plus 2x, it's two terms now, so it's binomial. So let's start with the operations with algebraic expression. As I said earlier, we have 4 major operations. Addition, we can add polynomials, we can subtract or find the difference of polynomials, we can also do multiplication, division of polynomials. Now, when we are adding or subtracting, we always use the term like terms. We always combine the like terms. The like terms means they have the same variable. The name of the variable, let's say x, should be the same, and the exponent should be the same. So for example, if I have x squared plus x, I cannot combine it because the exponents are different. They are not like terms. If I have x squared plus x squared, yes, the base is the same, the exponent is the same. So x squared plus x squared will give me 2x squared. So let's see this example here. Here we have 3x plus 2x. See, we have the same term, x and x. So the answer should be 5x. So we had 3 and 2 together and we keep that. Again, the term is the same, xx. Now, if I have 3x plus 2y, I cannot do anything. I can't combine it because the terms are different. Similarly, the difference also the same thing. In order to combine or find the difference of 2 or more terms, the terms have to be the same. So here we have 9xy minus 3xy. Of course, the term is xy. They are the same, xy. So I will combine 9 and 3. So 9 minus 3 will give me 6. So my solution will be 6xy. So this is an example of addition and subtraction. I don't have much example here again because the only thing we should know about addition and subtraction is that the terms have to be the same. When we say the term have to be the same, we mean the variable name and also the exponent have to be the same. So one more time, if I have 3x squared plus 2x, I cannot do anything because the first we have xx, but the first term is squared, x squared there. Exponent is 2. And the second term, the exponent is 1. So we cannot combine. So again, addition and subtraction, we always combine the like terms. And the like terms means we have to have the same base name, the same exponent numbers. So that's what we mean to say here is the terms with exactly the same variable factors are called like terms. So we can add or subtract like terms by adding or subtracting the coefficient of the variables. For example, 2x plus 3x, the coefficient of the two variables are 2 and 3. So I can add 2 and 3 and keep the x, which will be 5x. So like terms are constants. Like terms are constant or terms with the same variables raised to the same powers, as we said earlier. So if I have constant value 2 or any amount, it's a like terms. But when we have a variable or a monomial with a coefficient and a variable, then the term have to be the same, the exponent have to be the same, or the powers. So we're going to see some examples here. I have 4x cubed plus x squared minus 5x minus 7 plus minus 8x cubed minus 2x plus 1. So here I'm going to combine all the like terms. I have 4x cubed minus 8x cubed. The terms are the same. X cubed, s cubed. S squared, we don't have any s squared here, so we just leave s squared. Minus 5x minus 2x, the same term, so we can combine. And the two constant value minus 7 plus 1, we combine. So this is what we're going to do for s cubed. We combine it with minus 8s cubed. And that will give me minus 4s cubed. The reason why 8 is bigger than 4 and 8 is negative, so we keep the negative. Then second, we come to s squared, but we don't have no s squared on the right side. So s squared is by itself. Then next we have negative 5x, negative 2x. It's negative, negative, so we keep the negative sign. Then we combine the two, so we get negative 7x. And the last will be our constant value, negative 7 plus 1, and that will give us negative 6. So this will be our solution. Again, the goal here with addition and subtraction of polynomials is again combining the like terms. We can do the vertical method, whereby we combine it, same like doing a basic arithmetic operation. I make sure that I arrange the same terms together. And here we get 4x cubed plus x squared minus 7x minus 6. So when we are doing it in vertical way, well, we need to arrange all the terms, like terms together. So another example here, we have 6x cubed minus 4x plus 3, 9x cubed plus 6x minus 11. And another example, 2, 7y to the power 4 plus 9y squared minus 6 plus 3y cubed minus 10y squared minus 8. And another 2 examples. So we're going to solve this problem one at a time. Let's start with the first one. Okay, we have two like terms, x cubed, x cubed. So we get 15x cubed. We have x, oh yeah, we have another x. So we get minus 4x plus 6x. They are the same term. So that will give us plus 2x. We have two constant values, plus 3 minus 11. So that will give us minus 8. So again, addition, combining the like terms. Now let's see the next one. We have only y to the power 4, only 1. So we leave it. Then we come to y to the power 3rd. Okay, we have only 1 in the right side, so we leave it. And we come to the square y square. Okay, we have 2y square now. So plus 9 minus 10 will give me minus 1y square, which we normally write minus y square. And we have two constant values, minus 6 and minus 8. Since both numbers have the same sign, we add the values and keep the sign. So we get minus 14. Again, why we get minus 14? Because 6 is negative, 8 is negative value. So we keep the negative and we combine the two values. Now then we have the next one is vertical method, but again, it's already arranged for us. We can see all the like terms are together. So here we get 7x squared, negative, negative. So we get negative 9x plus 2 minus 7 will give me minus 5. Because why? The signs are opposite. And we keep the sign with the big value or the biggest value. In this case, 7 is negative, so we keep negative. The next one, we have the same term, m cubed, but we have 6 and 1. 1 is negative, so we get 5m cubed. M squared is only 1 by itself, so we bring it down, minus 2m squared. We have plus m minus 7m. Plus m means 1m, so 1 from 7 will give me 6. And since 7 is a negative sign, we keep the negative 6m. The constant value is only 1, so we get plus 10. So opposite of polynomial, now we're trying to do the addition and subtraction. The only thing we should know here is that, for example, if I have a subtraction and I have some terms in the parentheses, all we have to know is that the sign will change. If it's positive, the signs will remain the same. So if I have negative a plus b plus c, when I remove the parentheses, I will get negative a, negative b, and negative c. Because negative times positive is negative. Another negative times positive is negative. And the last one, negative times positive is negative. So when we are doing subtraction, it's the same concept. It's the same concept. But let's try this example first. So here we have x cubed plus 4x minus 9. So x cubed is positive, so we get negative x cubed because negative times positive is negative. 4x is positive, so positive times negative again is negative 4x. Now we have negative and negative. So we get positive 9. Same thing applied to this question 2. We have negative outside, so all the signs will change. So positive will give me negative y to the power 5th. Negative here, 2y cubed, so that will be positive 2y cubed. Positive 7y, so that will give me negative 7y cubed. And question number 3, the same thing again, the signs will change. So I have positive t to the power 4, so that will give me negative t to the power 4. Another positive t to the power 3, that will give me negative t to the power 3. Negative 9t, so that will give me positive 9t. Negative 2, so that will give me positive 2. And the last one, the same thing, all the signs are changing. So negative 5y cubed. Negative, so positive 8y squared. Positive, so negative 9y. And the last one, we have negative 3, so that will give us positive 3. So now we are going to start with the subtraction or difference of two polynomials. As we all saw the previous example, just the previous slide, our goal is that since we have negative sign, we are going to multiply with all the items in the parentheses, and the signs will change. So that's our main goal. This is the main reason why we did the previous example. So y squared is negative y squared now. Positive 2y is negative 2y now. Negative 9 now is positive 9 because of the negative sign outside the parentheses. Now we can do the same techniques we use for the addition of polynomials. Combine the like terms. So y squared, so that will cancel. Y squared minus y squared is 0. Then we have positive 5y and negative 2y, so that will give me positive 3y. Then we have positive 6 and positive 9, so that will give me positive 15. Next example, same thing. Let's remove the parentheses. So m squared is positive, it becomes negative. 2m is negative, it becomes positive. Negative 6 times negative becomes positive, also positive 6. Then now we combine the like term. We have 6m squared and negative m squared, so that will give me positive 5m squared. We have 4m plus 2m, so that will give us 6m. And it's positive, both are positive. Now we have plus 1 plus 6, so that will give us plus 7. So the concept is the same, addition and subtraction. The only thing we know is that parentheses is multiplication. So if I have a negative, as we can see the first example, since I have negative in front of the parentheses, I'll multiply negative by the first sign of the first term. The first term sign. So that will give me negative. The second term, the sign is positive and negative, so that will give me negative again. The third term I have negative, so that will change to positive because negative times negative is positive. Here we have application here, problem. They say a farmer must have the areas of 2 plots of land to determine the amount of seed to plant. So this farmer again have 2 plots of land. Now they will give us the area of a plot 1 or A can be represented by 3x squared plus 7x minus 5. The area of plot B can be represented by 5x squared minus 4x plus 11. So now they say we should write a polynomial that represents the total area of both plots of land. So we have 2 plots here, and the area of each plot represented by the polynomial, each polynomial. So we are going to write the first plot A, and the plot B is this. And we are finding what? had the sum of the two areas. So we just have to do addition here, combine the like terms. So we have 3x squared plus 5x squared. The terms are the same, so we combine it. 7x, 4x, the terms are the same, so we combine. Minus 5, so the constant value minus 5 and 11, the terms are the same, so we combine. Positive 11 and negative 5. Since the signs are opposite, we find a difference, which is 6. And it's positive because 11 is bigger than 5, and 11 is positive. So this is another question again. Here they say we should write an expression that represents the area of the shaded region in terms of x. So we have x plus 2, 2x plus 5, then 3 and 6. Here we are going to write an expression that represents the area of the shaded region in terms of x. So the shaded region is this small box here, and then the box here. So here you can see that the first question is like we have two rectangles, the bigger one and the smaller one. So we find here we are writing the expression will represent the area of the shaded region. So the rectangle, to find the area, will be the two side multiplied. So I'll get 6 multiplied by 2x plus 5. And that will be the area for the big side. Then the smaller side will be 3 times x plus 2. And then it's one object, so I have to add both together. So this will be our solution. The first area is what? 6 times 2x plus 5. This is a rectangle. The area of a rectangle is multiply again the two sides. The two sides here, they are the same. So it's like the length and the width. So 6 by 2x plus 5. Then the second also is the same. 3 times x plus 2. We have two areas, so we add them together. So our final solution will be 6 times 2x is 12x. 6 times 5 is 30, plus 3 times x is 3s, and 3 times 2 is 6. Then we combine the like terms. So we get 12x plus 3x, which will give me 15x. Then plus 30 plus 6, which will give me plus 36. So the same thing applies to the second question also. So we have the shaded area. We get 9 times 3x plus 7, same rectangle, so the length and the width. And this will give us, and also, again, the 9 times 3x plus 7 is the area of the whole thing. So we find the multiply. Then remember, there's some inner part which is not shaded. So we have to subtract 5 times x plus 2. So the area of this small part which is not shaded, we subtract it from the whole area of the object. But the question said that we are looking for the area of the shaded region. So this will give me 27x plus 63 minus 5x minus 10. And combining it, we get 27x minus 5x will give me 22x. Then plus 63 minus 10 will give me plus 53. The same concept, write an expression that represents the area of shaded in terms of the x. Again, the same step, but this time we see different measurements. So I'm going to write down both. So that's it. Now, x squared, we shouldn't worry about this. All we need to do is just a multiplication. So 7 times 6 x squared will give me 7 times 6, which is 42 x squared. Then 7 times 5, which is 35x. The same thing applies here. 5 times 3 is 15, so 15x squared. Then 5 times minus 2 will give me minus 10, then the x. Then we combine the like terms. So 42x squared plus 15x squared, that will give me 57x squared. Then 35x minus 10x, that will give me plus 25x. Got 35 minus 10 is 25 on the x. Same thing applied to the next question. So first I'll find the area of the whole object. A times 2x squared plus 4. And remember, we are trying to take the unshaded out. So it's minus 3 times x squared minus 8. Remove the parentheses, we get 16x squared. 8 times 2 is 16x squared. 8 times 4 is 32. Then minus 3x squared will give me, and minus 3 and 8 will give me negative times negative is positive. So 3 times 8 is 24. Then we combine the like terms. 16x squared minus 3x squared will give me positive 13x squared. Then plus 32 plus 24 will give me plus 56. So that's our product. Now let's solve more example here, product and quotient. Here I have a term, 3 terms. In multiplication, just multiply everything. So we get 8 times 2 times negative 3. And that's what we have here, 8 times 2 times negative 3. Then x times s cubed times x. So we have s times s cubed times x. Then y cubed times y squared. So what we're doing, we just multiply all the terms. Then remember, we did the rules of exponent already, and that was lecture number 3, rules of exponent. So I have the same base, x and x, so I'll add what? The exponent. 1 plus 3 will give me 4. Plus 1 again will give me 5. So we get s to the power 5. Then y also we have 3 plus 1 plus 2. So y to the power 6. Then we multiply 8 times 2 times negative 3. And I think that will give me negative 48. So we get negative 48, s to the power 5, y to the power 6. Now division, the same concept, divide the numerator. So this will be my numerator, and this will be my denominator. So we divide it. 3 can go into negative 15, that will give me negative 5. Then if I have s squared divided by x, remember loss of exponent, when we are dividing and the base are the same, we subtract the denominator exponent from the numerator. So we get 2 minus 1. So we get x. Then we get 3 minus 5. Again, the numerator exponent is bigger. So we get negative 2. We can take a reciprocal of negative 2, which will give us 1 over y squared. So let's see the answer now. Negative 15 by 3, s squared by x, y cubed by y to the power 5. And we get negative 5, x, and y negative 2, but it's the same as 1 over y squared. We take the reciprocal of it. Again, we studied this in the rules of exponents, lecture number 3. So this will be our final solution, negative 5x divided by y squared. Now, so to multiply 2 polynomials, write one of the polynomials above the other, as we are doing here. And it's like we are doing a regular arithmetic operation for multiplication. So I'll take the first term x, multiply by everything. So I'll say x times 3x, the answer is 3x squared. X times 4xy, the answer will be 4x squared y. And I'm not mentioning the sign y because s is positive and all the terms at the top, they are all positive. So we can see our answers are all positive. So s times 3y will give me 3sy. Now down, remember, negative and times positive is negative. So using negative 2y to multiply all the terms here, my answers will be negatives. So here, if I have binomial or even trinomial 3 terms, all I need to do, take each term, multiply by everything, second term multiply by everything. So minus 2y times 3s will give me minus 6sy. Minus 2y times positive 4xy will give me minus 8xy squared. Then minus 2 times 2y times 3y. Y will give me y squared. Negative 2 times 3 will give me 6, negative 6. Then now we combine the like terms. S squared is by itself, so 3s squared. S squared y also by itself, so 4s squared y. Then we have xy, sy, so plus 3 minus 6 will give me minus 3. Then sy squared is by itself, and y squared also by itself, so we get negative sy squared, negative 6y squared. We also have what we call the special product. This is called the perfect square. We have s plus a, s plus b is the same as s plus a all square. Sorry. It's s plus a and s plus b. They are not the same. If it's a and a, then I'll say s plus a all square. So here we can open the parentheses and we get s squared plus a plus bx plus ab. Now, if we get as plus b or cs plus d, we multiply all the term by each other. What the reason why we get, for example, the first a, we have s plus a times s plus b. So I'll use s to multiply s plus b, and I'll use a to multiply s plus b. Then I'll combine the like terms. The like terms you are going to get will be ax plus bx. So that's why we have a plus b or x. Because first we get, if we do the FOIL, F-O-I-L, we do the first terms, s times s is s squared. Then we do the outside. The outside will be what? A times b, so AB. Then we do the inside. The inside will be AX. Then the outside, A and B. And that's what we get here. The same thing applied to B also. We multiply each term, and that will be our solution. So that's what we use, the FOIL method. FOIL means, and let's go back here again. Multiply the first terms. So the first term will be x and x. Then multiply the outside term. The outside term will be a and b. Then I stand for inside. The inside will be a and x. And then the last one, then we multiply a and b. So that is the L. L is the last term. So that's what we explain here. We can obtain this product by finding the product of the first term, the outside term, inside term, and the last term. So if I'm using the FOIL method here, the first term will be s times x. Outside term will be x times 3. Inside term will be minus 4 times x. And the last term, of course, for each of these is negative 4 times positive 3. So that's what we did here. The first term is x squared y because s times x. Outside is x times positive 3, 3x. Inside is negative 4 times x. We should be careful with the sign also, since negative 4 and positive x to give me negative 4x. And the last term, negative 4 times positive 3, so that will give me negative 12. Then we'll remove the parentheses. We get s squared minus s minus 12. We combine the like terms, so we get the minus 4s plus 3s, that will give me minus x. And the b, the same step, so we get 3x times 2s, that is a 6s squared. Then we get 3s outside times 5, that will give me 15x. Inside will be 2 times 2x, that will give me 4x. And the last term will be 2 times 10, 2 times 5, that will give me 10. So one more time, FOIL means FOIL. F is the first term, 3x times 2x. Outside, of course, 3x is outside, 5 is also outside. So we get 3x times 5, 15x. Inside is 2 and 2x inside. So we get 4x. And the last term for each is 2 times positive 5, so we get positive 10. Then we combine the like term of 15x and 4x. And that will give me 19x. So 6x squared plus 19x plus 10. So these are some of the additional special products. And this is what I was trying to set for the perfect square. If I have s plus a times s plus a, then it's s plus a squared. And this is s squared plus 2ax plus ax squared. Again, most of us here in this class have taken Introduction to College Algebra. We went through these formulas in the developmental mathematics, so we know this is perfect square. Again, if you can't remember this formula, then all you need to do is just multiply s plus a by itself, so square, so it will be s plus a times s plus a, and use the FOIL method. You get s squared plus 2as plus a squared. The same thing with the s minus a squared means multiply s minus a and another s minus a. Use the FOIL method, you get s squared minus 2as plus a squared. Then this is the third one, is called the difference of two squared. If I have s plus a times s minus a, the answer will be s squared minus as. Now, if you can't remember the formula as usual, use the FOIL method to multiply everything here. You get s squared minus as squared. We can do this now. Let's say the first term is s and s, so we get s squared. Then the next we have the outside, so we get s times minus a, so we get minus ax. But look inside. Inside is plus a plus x. So I'll get minus as plus as, so they'll cancel each other. Then the last, which is the last term, will be a times minus a, positive and minus, so I'll get minus as squared. Also the cube, if you can remember this formula from basic college algebra, that's fine. But if not, cube means you multiply the same term 3 times. So we get s plus a times s plus a times s plus 8. When you multiply everything, you get and combine the like terms together, you get s cubed plus 3a s squared plus 3a squared x plus s cubed. We also have the difference of it, which is s minus a cubed will give me s cubed minus 3as squared plus 3s squared a squared x minus s cubed. So let's perform the following examples. Let's do the first one. So let's look, first of all, we have to see if there's any like terms, because here we are saying addition, subtraction, subtraction, subtraction. And I have a parenthesis here. So the first thing I will do is to remove the parenthesis for the first question. So let's try the first one. This is what we get. Why we get this? We remove the parentheses and we combine the like terms. Let's go back to the question. You can see that we have a cube. Oh, sorry. We have cube, and we have another cube here, and we have another cube here. This cube will be negative because we have parentheses here and it's positive. So I'll get negative cube, negative 5, and also 3 positive. So this means I'll get 3 square root of 3. I was saying cube, excuse me, not cube, square root of 3. So 3 square root of 3, negative 5 square root of 3, minus square root of 3. The other one is y, so I get 4x square root of y, 11s square root of y. Then this time I have negative and negative, so positive s. So we see that square root of 3 have 3 terms, square root of y have 3 terms, and that's what we get here. 3 minus 5 minus 1, then 4 minus 11 plus 1 x. S is common among all of the terms, so we bring s outside. Then we do our total combination, so we get 3 minus 5 minus 3 will give me minus 6, positive 3, that will give me minus 3. Then we keep the 10. 4 minus 11 plus 1, that will give me 10, that will give me negative 6, so it's negative 6. Why 6x is here? Because when you look at the terms, s is common, so we take the common, we factorize it 4x, 11x, and x. So we factorize that out. Now let's try the second question. The second question here, we are going to use the rules of exponent because we can see all the bases are the same and we are multiplying x to the power 3 by 2 by the terms in the parentheses. If I want to, I can combine these two terms first if it's possible, or I'll just multiply the outside term with everything inside. So it's up to us, and that's the best way we did. So s 3 to the power 2 times x to the power half minus s to the power 3, 2 times s to the power negative 1/2. Then now we can combine the, because it's multiplication. So it will be 3 by 2 plus 1 by 2. And here also 3 by 2 minus 1 by 2. And this is what we get. 3 by 2 plus half, that will give me 2 because I'll get 4 over 2. So give me 2. 3 by 2 minus half, that will give me 1. So I get only x. So my answer will be x squared minus x. Now, can I combine these two terms? Of course, no. Why? Because this is subtraction. If it's multiplication, I can multiply s squared by x, and that will give me s cubed. But if it's addition or subtraction, I cannot combine s squared and x because the exponents are different. So they are not alike terms. So the last one, again, we have everything here raised to the power 2. So I'm going to use the power 2 to multiply all the powers in the parentheses, and that's what we did here. So I get x to the power half times 2 minus 2x half s 1/3 plus s 1/3 and then s 1/3, because this is perfect square. Remember when we have, let's say if I have a plus b all square, it's a squared plus 2ab plus b squared. That's why we have 2. This is minus now, so minus 2. Then the two terms are x half times s 1/3. And the last term we have to square it. The first term also we have to, so that's why I was saying we square the two terms. Then minus 2 times the two terms. This is the perfect square. Now, if you cannot remember this, let's go back. I was explaining it before. And this is what we have. S minus a all squared. So it will be s squared minus 2as plus a squared. The last term plus a squared. The first term a squared. Then minus 2 multiply the two terms. Now, if you can't remember this, then the only thing, multiply the two terms, because anything that is square means we multiply it by itself twice. So if I like, that's what we can do. Otherwise, we just write the formula. So this will give me x, because half times 2 is 1. And 1/3, so this will give me 2/3, because 1/3 times 2, 2/3. Then we have x half times s 1/3. So we can combine these two exponents, and that give me 5, 6. Now I can't combine no more because all the three terms are different. Their exponents are different. So that'll be our final solution. The d here, again, if you want to, you can multiply each term using the form. Square root of x times square root of x, square root of x times -2 plus 2 times square root of x, then plus 2 times -2, and write the answer. But since everything in this, the two terms are the same, square root of x, square root of x, 2 and 2, their signs are opposite. This is what we call the difference of two squares. So the answer will be square root of x squared minus 2 squared, which will be x minus 4. So we don't need to multiply all the terms just to save the time. Look, if the terms are the same, and one is positive and one is negative, and it's binomial, it's only two terms, then we have difference of two squares. So the answer will be x minus 4. Also, sometimes we may have a division question, like example here, we have trinomial by binomial. Then we have to do a long division. If it's only monomial, I can just divide the one term with the numerator with the denominator. But here we have to, so I have 4s cubed plus 4s squared plus 5 by 2s squared plus 1. So this is my denominator is 2s squared plus 1. So it will be 4s cubed plus 4s squared plus, I'm adding 0 here because we want to have an increasing order of the exponent. So from 3 to 1, then constant value. But as we can see, in our term here, there is no x. So first thing we do, divide the first term 4s cubed by 2s squared. And that will give me 2x. Now, when you get the 2x, you multiply by the terms here. So I multiply 2s by 2s squared and by plus 1. And I get 4s cubed plus 2x. Then I'll find the difference of the two. Now, here will be minus. So 4s cubed minus 4s cubed will be 0. 4s squared is by itself. There's no 4s squared down here. So we get 4s squared. Now, 0x minus 2s will give me minus 2s now. Why I said minus? Because when you finish, you subtract it from the top. So I'm supposed to write minus here. And this is our solution. Now, when you reach this solution, now you are going to divide the first term here, which now is the 4s squared, by 2x squared. And that will give me 2. Then I'll repeat the same thing. I will multiply the 2 by the two terms here again, 2s squared plus 1. And that will give me 4s squared plus 2. Then I'm going to subtract that from 4s squared minus 2s plus 5. So which means the down 4s squared will change to negative, plus 2 also will change to negative. So the 4s squared will cancel the 4s squared here. We have negative 2s by itself, so it comes down. This time, positive 2 is negative 2 now, so we get positive 3. Then when I reach here, I cannot go further no more. Why? Because the degree of the answer of the last term here is 1, but the degree of the denominator is 2. So we cannot do anything. So this will be like a remainder. So that's why here they say the degree minus 2s plus 3 is less than the degree of 2s squared plus 1, which is the denominator. So if that's the case, my answer will be 2s plus 2, remainder 2s squared plus 1. Or in this case, they just wrote the answer 2s minus 2s plus 3 divided by 2s squared plus 1. Because I'm going to divide the last expression here by the denominator. Or I can just write remainder minus 2s plus 3. So yes, this is some of the few division again examples here. We can see that, so, as I said earlier, when we have a monomial. So I'm going to divide the 3s squared y with each term. So my correct answer here will be 3x squared y divided by 3x squared y is 1. 6 divided by 3 is 2. X to the power 5 divided by x squared will be 5 minus 2 is 3. And y squared divided by y to be 2 minus 1, so it's 1. So it seems like the B is correct answer so far. Then the last, I'm going to divide minus 9 by 3, which will give me minus 3. X to the power 7 and x squared will be 7 minus 2, so that will give me 5. Y cubed divided by y will be y squared, so the correct answer will be B. Here again, we have a monomial, so we don't have to do the long division. I'll just use the one term to divide each of the terms. So I divide 3x squared y by 3x squared y, 6x to the power 5 y squared by 3xy, then minus 9x to the power 7 y cubed by 3x squared y also. So B is the correct answer. So we use the long division. One more example here. See, here I have a binomial now, so I don't have no other option. Long division is the last option. So x minus 5, x squared minus 2x minus 15. The first thing we do, divide x squared, the first term, by the first term here, x. And you put your answer down, your answer will be x. Then you multiply x by x minus 5. Then that will give me x squared minus 5x. This time I put the minus here. Then we have to change the sign down here. So when we change the sign down, x squared minus x squared will cancel. This with minus 5x will change to plus 5x. So plus 5x minus 2x will give me 3x. Then minus 15 is by itself, so it will come down. Then the next step, we are going to divide 3x by x, and we get 3. Then we multiply the 3 by x minus 5, so that will give us 3x minus 15. Then we subtract. And luckily, this will be 0, so this means we don't have no remainder like the previous example. So our answer will be x plus 3. Now, if you want to check if your answer is correct, multiply x plus 3 by x minus 5. You should get x squared minus 2x minus 15. Again, thank you for this lecture. In this lecture, again, is our Mathematics 164 at New Jersey City University. And here we cover the polynomials and also the operations, and basically addition, subtraction, division, and multiplication of polynomials. We also talk about what is a monomial, what is a binomial, and like terms, etc. So again, wish everybody the best, and then thank you.